headed by our President, Mr. Hideki Toide. Our main products are the SRC silicon connector and the BSS or battery state sensor. These are the FAIA management system certifications.
Circle introduction. The team aims to focus on learning from past issues or problems, enhance the process, optimize workflows, and maintain customer satisfaction at its fullest. And this is our QCC Competition Achievement Awards.
Theme selection. In what area should we focus?
Previous year 2023 and fiscal year 2024, we mainly focus on the internal quality issues on the process of dispense and injection molding machine in terms of machine downtime improvement.
For the fiscal year 2025, Circle decided to focus the external issues on customer claims, improve into strengthen quality mindset, and achieve zero defect and high quality product.
Aligning the TRP QCC competition objective to strengthen quality mindset in order to achieve zero defect. Zero defect equals
No customer claim equals
customer satisfaction. Yes!
This is FAIA Customer Claim Defect PPM of fiscal year 2023. November 2023 have 2.13 PPM and we are
Out of target.
FUR 011, wrong neutral pin issue.
Focus point.
good product. 6RP model using orange lock pin but received by customers. 6RP using green lock pin.
No good. Problem identification. Based on the FER 01120 channel GPSMD drawing, this product shall use an orange lock pin to differentiate to other model, but the customer received a green lock pin. With this condition, our problem is identified. Wrong lock pin used to FER 01120 channel JP model. Team statement, elimination of wrong lock pin used to SRC assembly product at FER 011 assembly line through foolproofing methods and process improvement activities. Target setting, zero customer claim.
Related to wrong usage of lock pin colors at SRC assembly products. Timing plan. Activity will run from first week of November 2023 to second quarter of 2024.
As of present situation, this is the FER 011 SRC assembly line composed of 10 manpower. This is the actual assembly line and the product output or the SRC assembly. The problem occurred at
Final testing process.
how does the wrong lock pin occur?
Before we analyze the occurrence of the problem, let's understand this QC sampling procedure first.
During mass production, QC personnel pulls out one product, conduct QC sampling process offline.
QC sampling process. First, sleep fitness check. Second, pigtail length measurement. Third, product weight checking. Fourth, meeting connector insertion. And 5, noise checking and visual inspection.
During noise checking, the lock pin is removed.
Why we need to understand that process?
Because this is the occurrence of the abnormal condition.
This is the normal condition.
Step 1. Get line QC sample.
Line QC will get the product from the assembly line. Get the line QC sample from the container.
Step 2. QC sampling process.
Submission of sample to conduct sampling process.
Step 3. Endorsement to production team leader.
The product will be endorsed to team leader.
Step 4. Retesting by team leader.
1. Function testing. Return product, set the product in neutral position, insertion of new lock pin. 2. Final testing. Image file capturing. Record image of the lock pin condition and product in neutral position.
Step 5. 100% visual inspection.
Endorse the tested product to line QC.
Line QC will conduct 100% inspection.
Step 6. 200% visual inspection.
Give the retested product to SRC QC.
SRC QC will conduct 200% visual inspection.
Step 7. Return of sample to polytainer.
Line QC will place the retested product to polytainer.
And this is how customer claim takes place.
Abnormal condition.
Step 1. Get line QC sample. Step 2. QC sampling process.
Changing point.
Set up or change model during QC sampling process from FUR 01120 channel JP to FUR 01122 channel HR3. And these are the changing points. Differences of both models, number of pigtails, color black pins, stator housing, and barcode label.
Step 3. Endorsement to production team leader. Step 4. Retesting by team leader.
Function testing.
Green lock pin inserted and not detected. First blood.
Final testing.
Green lock pin not detected. Double kill.
100% visual inspection.
Green lock pin not detected. Triple kill.
200% visual inspection.
Green lock pin not detected. Maniac.
Return of sample to polytainer.
Green lock pin not detected. Savage. Resulting to customer claim.
Aray ko!
To To summarize, customer claim occurred during the change model or setup assembly line during QC sampling process or between step 2 and step 3.
Therefore, we can apply actions between step 2 and step 3 to prevent the problem reoccurrence.
Using YY analysis, we identify the root cause of the problem. Problem phenomenon. Deliver wrong lock pin color to customer.
Y1,
Different lock pin color was attached to the SRC.
Y2,
QC line sample is directly put in the polytainer without prior checking.
Y3,
Verification of product was not conducted.
Y4,
Work process deviation.
Judgment.
No good.
Products undergo 200% visual inspection but wrong lock pin not detected.
Conclusion.
Factor.
Y2,
Lock pin was not fully checked after QC line sampling.
Y3,
Focus on the other checkpoints of the product.
Y4,
Work process deviation.
Judgment.
No good.
Sequence of checking was not conducted correctly.
Conclusion.
Factor.
Through brainstorming, the circle proposed 4 countermeasures to the root cause
Work process deviation.
and came up with a final countermeasure.
Foolproofing of the process. But how can we do it?
by improving the process between step 2 and step 3. Process to improve,
Foolproofing or pokayoke.
Implementation of countermeasures. PDCA plan. We have 2 phases of countermeasures. 1. Improvement of QC sample container. 2. Software improvement.
PDCA do Action 1. Provision of Ziploc bag as a container of lock pin in use before QC sampling process.
Before inside the container, 1 green lock pin tag, 1 yellow lock pin tag. New lock pin was get from the function tester supply part during the work.
after yellow lock pin tag is attached with Ziploc bag, together with specific lock pin used before QC sampling process.
Result, correct lock pin will be used based on the lock pin inside the Ziploc bag placed before QC sampling process.
Risk assessment 1. No lock pin placed due to damage, Ziploc bag or missing Ziploc bag.
Mitigate the risk by establishing spare control and replace it based on the conditions.
First phase action complete.
Action 2. Modification of program of finished good validation software with additional detection of lock pin.
Before, during step 1, line QC uses FG validation laptop to record the product for QC sampling.
Process of validating the product. A. Reading of barcode label.
B. Register to the program.
D1. QC sampling process.
C. Retorting image file recording.
D. Reading of barcode label and register to the program.
E. Play sample to polytainer. And this is our improvement point.
After D1, notification of the correct lock pin in use of the pulled out product from QC sampling process.
Result, the program now have notifications of correct lock pin use.
Before, no checking of lock pin use.
After, validates the data including correct lock pin use.
Result, the FG validation program can show the correct lock pin use.
Risk assessment 2. No confirmation message to the line QC if the lock pin shown is correct or NG.
Risk assessment action. Improve the program by adding a confirmation message.
Risk assessment action. Before, notify only the line QC of what correct lock pin shall be used.
After, a pop-up window will show to verify line QC if the lock pin used is correct or NG.
Or simply, from information to confirmation. To summarize, before, program can only show the correct lock pin use.
After, line QC can confirm the correct lock pin in use on the program. If NG or wrong lock pin, an error pop-up message will show and data log will show failed and NG. If good or correct lock pin, data log will show okay to the remarks and good to the confirmation.
Result, the FG validation program can show and confirm the correct lock pin use.
Risk assessment 3. Scenario of deletion or corruption of program.
Mitigate the risk by keeping backup software saved in FEA file server and OneDrive.
Risk assessment 4. Data loss or missing data recording.
Mitigate the risk by having backup recording. First is FEA file server, next is QC laptop, and third is SRC QC USB.
Second phase action complete.
PDCA check, SPC external R graph verification.
Zero defect PPM for any type of defect after the implementation of countermeasure.
0 ppm.
PDCA Act, revision of documents that includes
Countermeasure 1 and Countermeasure 2. PDCA cycle plan on schedule timing plan.
2. Foolproofing the process.
Check, external monitoring.
Revision of standard operating procedure.
Continuous improvement. Yosh!
This is the plan and actual activity schedule.
Result of countermeasure from April 2024 to October 2025. 0
Customer claim related to wrong lock pin. Target achieved! Hooray!
These are the standardized documents and activities in our QCC project.
Horizontal development. Implemented assembly model 17, completion rate
100%! Hooray! Tangible benefits. If the customer claim will not be corrected, the organization will incur special inspection, sorting costs.
Having an effective countermeasure based on the defect DPM, we can prevent a sorting cost of
255,000 Japanese yen.
intangible benefit. Quality of product is very critical to customer satisfaction.
Understanding situation is very important.
Continuous improvement shall be our practice of every individual.
Every action comes with a risk. Remember the 40s.
Treat, transfer, tolerate, and terminate. Victory!
Future plan.
Improvement of actions to other issues related to quality to continuously achieve the zero PPM.
Before we end our presentation, we want to leave you a simple quote. Coming together is the beginning,
Staying together is progress,
and working together is success. Once again, we are Furukawa Electric Auto Parts Philippines, representing Cellofull, superb elimination by foolproofing, finishing defect on locked-in customer claim. Maraming salamat po.